this?
This is geometry. All right. Oh yeah. All right. So P-6. Today we're going to look at complex numbers, and we have reviewed complex numbers, but there's some additional things that we need to talk about. So I'm going to do, a brief review with some of it. Which was not helpful.
No, it doesn't.
All right, so before we can talk about complex numbers, let's talk about what I is again. So remember that I is equal to the square root of negative 1. We never write the square root of negative 1, we always write I. So I is the only complex number that we'll leave as I. Any other complex number, I squared, I cubed, I to the fourth, I to the fifth, etc., must be broken down into one of these 4 other items. And so I squared would be square root of negative 1 times square root of negative 1, which is what? Just negative 1. Anytime you take a radical and multiply it by itself, you get the number under that radical. And then I cubed is essentially these two multiplied. Since we don't use the square root of negative 1, we're going to multiply I times I squared. So I times negative 1 gives us negative I. And so we can leave something in terms of I. That's okay. And then I to the fourth is I squared times I squared. So what's negative 1 times negative 1? Just 1. Those are the only 4 forms. All other powers of I will fall into this pattern. So it goes in a pattern of 4. So if you have I to the fifth, that's I to the fourth times I. Well, I to the fourth is 1 times I is I. So the pattern starts all over again. I to the sixth is going to be negative 1, I to the seventh, negative I to the 8th, 1, and so forth. So it goes in multiples of 4. So then we also need to talk about standard form. Your homework is going to want a lot of your answers in what they call standard form. If you don't put it in standard form, that'll be why it's wrong. And they'll probably tell you it's not in standard form. So standard form is A plus BI, and the I must come second. The A is your real part of this complex number. Thank you. Thank you. And your BI is the imaginary part of that complex number, and the whole thing together, both parts together, form the complex number itself. So instead of just having a real number system, we now have the complex number system, which is broken into a real part and an imaginary part. Together they make that complex number. So, example 1, we are going to add or subtract. So this should be the easy part. Part A, 7 minus 3i plus 4 plus 5i. So there's addition here, so technically we really don't need the parentheses. All you're looking for are like terms. Like terms would be the real part and the imaginary part. So you've got the 7 and the 4 gives you 11. And then we have a negative 3i and a negative 5i. Follow your integer rules. Say that again. I said negative 3i. Did I say negative 5i? Yeah, I meant a positive 5i. Ooh, so see, this is what happens when I talk. So that's not equal to 5i. What is it equal to? Yep. Let's just test. All right, so that one, not a big deal. And again, you have to write the 11 first and then the 2i. If you write them in reverse, even though addition is commutative, they won't accept it because it's not proper standard form. So part B is the subtraction. So we have parentheses 2 minus I and parentheses minus parentheses 8 plus 3i. So the only difference is we have to change all subtraction to addition by adding the opposite. So because parentheses follows that subtraction sign, everything in the parentheses changes signs. So we get plus and minus minus. Now we just do what we did above. Combine your real part, what do you get? Negative 6. Combine your imaginary part, what do you get? Negative 5i. Oh, what is my problem today? Good heavens. It's because I'm in a hurry, it's happening. Yeah. That's not good. I'll just lecture double then. I'll talk even faster. All right, so that part you're going to have as a piece of cake. No big deal. But example 2, we start getting to multiplication, which is where some of your errors will start to occur. Here we're going to multiply. So we have 2 plus 3i times 5 minus I. So we're going to FOIL. So if I multiply 2 times 5, that's 10. 2 times negative I, negative 2i. 3 times 5, positive 15i, and you will see me line things up where they're like terms. And then 3 times a negative 1 gives me a negative 3. I times I is I squared. You'll get to the point where you'll skip some of these steps I'm going to put in here, but because it's your notes, we're not going to skip them. So if I add like terms, I get 10. Subtract, get this on the larger, I get positive 13i. Then this I squared, we can never write any I to a power other than 1. So you have to convert the I squared to its value, which is what? Negative 1. So I end up with 10 plus 13i. Negative 3 times negative 1 is a positive 3. So really what's happening with that I squared, it changes its coefficient to its opposite sign. And then you drop the I squared. You'll essentially start doing that. You'll go directly from here to here. And then I have to combine any like terms. So my 10 and my 3 comes in front. So I've got 13 plus 13i. You do not factor it. Factored, it won't be in proper standard form. This piece of cake so far. It gets harder. All right, so example 3. We okay? Okay. So example 3. We are going to raise, so we will be raising and you want some room for this one, raising a complex number to a power. So this is where it can become a little hairy, depending upon what problem they give you. So in this case, we've got if z is equal to 1/2 plus the square root of 3 over 2i, find z squared and z cubed. So I'm going to find z squared first, because isn't z cubed just z squared times z? So if I find z squared first, I can use that answer when finding z cubed. So let's start off with z squared equals. If I were you, I wouldn't do it in my head. I would actually write it out. 1/2 plus radical 3 over 2i times 1/2 plus radical 3 over 2i. And then we're going to FOIL that. So I have 1/2 times 1/2, which is 1/4. Be careful here. 1/2 times that ugly guy there. So we got 1 times radical 3, that's a positive radical 3. 2 times 2 over 4, and then tack on the I. Okay with that? So then we're going to distribute the radical 3 over 2I, the 1/2. So same thing, I get a radical 3 times 1 is a positive radical 3. 2 times 2 is over 4, and it's an I. So I have 2 of them that are exactly alike. And then finally, I've got a positive times a positive, which is a positive. What's rad 3 times rad 3? Just 3. 2 times 2 is 4, and then I times I is I squared. So we are going to take care of that I squared immediately. So let's collect like terms. I get 1/4 plus, if I have one of these and I'm adding another one of those, so I have 2 of these. So it's 2 radical 3 over 4 I, because we're adding like terms, the variable string doesn't change, we just add the coefficients. And then plus 3/4 times, instead of I squared, that becomes a negative 1. So will it freak you out if I do this? This is my like term, here and here, right? Isn't this really a negative 3/4? So what's a positive 1 that have the same denominator? What's a positive 1 and a negative 3? Negative 2/4, which reduces to what? So I get negative 1/2. And then I have this. Doesn't the 2 cancel into the 4 twice? So I'm left with negative 1/2 plus a radical 3 over 2I. So oddly enough, when I took z and squared it, the only thing that happened was the 1/2 turned to a negative on this particular example. We'd have to make a hypothesis to see if that would work for everything with a complex number. So then we're going to look at, let's look at z cubed. Z cubed. Isn't z cubed equal to z squared times z? So we're going to take this is our z squared, so this right here equals our z squared. We're going to take that value and use that for z squared, so negative 1/2 plus the square root of 3 over 2I. Then I'm going to multiply it by z. Z is positive 1/2 plus radical 3 over 2I. If you think about this, the only thing that's different here are these two. If I switch these two terms around, I'd have rad 3 over 2I minus 1/2, rad 3 over 2I plus 1/2. Isn't that the difference of 2 squares factor pattern? You should anticipate your inner and outer terms canceling. And an interesting thing occurs when you have the difference of 2 squares factor pattern with a complex number, which we'll talk about here in just a minute. But let's see what happens. So let's distribute. Negative 1/2 times positive 1/2 is negative 1/4. Negative 1/2 times this little guy. So a negative times a positive is a negative. 1 times rad 3 is rad 3. 2 times 2 is 4. And then tack on the I. Bit by bit, piece by piece. Then we're going to distribute the rad 3 over 2I. So we multiply that to the 1/2, I get a positive. Rad 3 times 1 is rad 3. 2 times 2 is 4, so over 4, and tack on the I. Won't those cancel? Opposite signs. Then multiply to itself, so you get a positive. Rad 3 times rad 3 is 3. 2 times 2 is 4. I times I is I squared. Oops, you didn't tell me you couldn't see it. There we go. So then we end up with negative 1/4. These cancel. This becomes, because I'm going to replace the I squared, this becomes plus 3/4 times negative 1. Doesn't this equal negative 1/4 plus a negative 3/4? What's negative 1 plus a negative 3? Negative 4 over 4, which is negative 1. So z squared turns out to be just a real number, -1. So interestingly enough, when we multiply the difference of two squares factor pattern together, we get rid of the imaginary part. So that brings me to my discussion of conjugates. Do you remember that we cannot have a radical in a denominator? Right? So if I have an imaginary number in a denominator, technically, if there's an I in there, isn't that the square root of -1? If I have an imaginary number in a denominator, I technically have a square root in the denominator, and you can't have that. So we're going to have to use conjugates. So conjugates would be if I have a complex number in the form of whatever form it is, a plus bi, to get to its conjugate, all we do is write its difference of two squares factor pattern. So these are conjugates of each other. All you do is change the middle sign. You don't change the sign of the first number. All you do is change the middle sign. And as you can see up here, we got rid of the imaginary part. This could have been written quite easily as radical 3 over 2i minus 1/2 times, squeeze it in here, radical 3 over 2i plus 1/2. They are conjugates of each other, and it is the difference of two squares factor pattern. And multiplying them out gets rid of the imaginary part. So that if I had, if you recall, if you had 1 over 3 minus the square root of 2 in algebra 1, 2, or 3, 4, the conjugate was its difference of two squares factor pattern 3 plus the square root of 2. You would have to multiply that to the top and bottom to get rid of that radical. Same thing occurs with imaginary numbers. If I had 1 over 3 minus 2i, this is no different than 3 minus 2 times the square root of -1. It's a radical in the denominator. So to get rid of that, we'd multiply by its conjugate, 3 plus 2i, top and bottom. And so we're going to do some of that here in a minute. You ready? I'll let you write it. Yes.
So for the left problem, it's 1 over
3 minus the rad 2. Oh, I forgot. I put a 3 up there, didn't I? Yep. Thank you. Good catch. Yeah, we would want that to be exactly the same number, wouldn't we? Huh? It won't go up much further. That's as far as we go. Sorry. We only have 2 more examples. Are we good? Can I flip? Yeah. Okay. So, example 4. So working with the theory of conjugates and fractions, we are going to divide. So part A, we have 3 over 2 minus I. So normally we'd leave it like that, but we have an imaginary number in the denominator. Can't have that. So what is its conjugate? 2 plus I. We're going to multiply top and bottom by 2 plus I. So distribute. 3 times 2 is 6. 3 times I is positive 3I over, and I encourage you, we are in pre-calc, to be using a squared minus b squared as you're multiplying. You could FOIL, your inner and outer terms are going to cancel just like we did previously, but use your shortcut. A squared means you're going to take 2 times 2, which is 4, minus, then take the last two terms, I times I is I squared. So skip the foiling and go to a squared minus b squared equals, we could factor out a 3, but let's see if it's going to do us any good. Isn't this I squared really a negative 1? So we've got 6 plus 3I over 4 minus a negative 1. So 6 plus 3I over, what's 4 minus a negative 1? 5. Now, a lot of you are going to want to leave your answer this way. Math Excel is going to ask you, and most textbooks are going to ask you to write your answer in standard form. This is not considered standard form. Remember, standard form is A plus BI. Completely separate the real part from the imaginary part. And so we have to perform this division. So we're going to break it apart into 6 over 5, whatever the sign is here in the middle, in this case plus, 3I, or I'm going to actually even write it as 3/5 with an I hanging out to the side. Don't put the I in the fraction. That is how Math Excel is going to run it. So don't put the I in the fraction. Put it as a fractional coefficient with the I hanging out to the side. Yes? Yep. Because we're going to use these later on as ordered pairs. And you've got to start looking at it in terms of standard form. So it's uncomfortable, but there it is. All right, part B. Part B is a little bit more complicated. This time we have 5 plus I divided by 2 minus 3I. So again, we can't have I in the denominator, so what's its conjugate? 2 plus 3I. But this time we have a binomial in the numerator, so we're going to have to FOIL. So 5 times 2 is 10. 5 times 3I is 15I. Then I times 2 is 2I. And I times 3I is positive 3I squared. All divided by, use your difference of two squares factor pattern. So take the first two terms, square it, so 2 times 2 is 4, minus, multiply these two terms together, 3I times 3I, 9I squared. Then we're going to combine like terms. So I've got a 10, 15I and 2I is 17I. This 3I squared, can't I at this point just start changing the sign? That's a negative 1, right? A negative 1 times 3 makes this a minus 3. All I did was change the sign, negative 1 times 3. All divided by 4. What does this I squared do to the minus 9? It changes that sign as well to a plus 9. So we have 10 minus 3 are our like terms, 7 plus 17I, all divided by 13. Is that your final answer? Nope. Put it into standard form. And if you could reduce when you put it into standard form, you should, but neither one of these did. So 7 over 13, the sign here happens to be a plus again, but it could be a minus. And then 13. I'm going to take the I out of the fraction. So put the I hanging out to the side. Okay, so that standard form is somewhat new to you, or at least a reminder of what perhaps you were told before. Last question. We are going to do example 5, and we are going to solve. And all they're going to say is solve. We've got x squared plus x plus 1 equals 0. We've learned a lot of factoring or solving methods. One of them is factoring, using the quadratic formula, completing the square. Those are the big ones, right? Factoring is generally what I'll try to do first because it's quicker. The bookends are 1 times 1, which is 1. Since it's positive, we're adding the factors of 1 to get our middle term of 1. Are there any factors of 1 that add to give you 1? 1 and 1 is 2. There's none, so it's not factorable. So then we have to go to completing the square of the quadratic formula. B is not even. So if I take this and divide it by 2, I have a fraction. Do you want to complete the square with a fraction? I choose not to. I wouldn't if I were you. So then get in the habit of writing out, because we're going to do the quadratic formula, A equals B equals C equals. So what's A? 1, B, 1, C, 1. So again, x is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I had a student from a new country that spoke very little English, and so I sang this song yesterday. I think she thought I was crazy. She just started laughing.
Are we going to have fun on this?
No, remember? Told you. All of these put on flashcards. You should have been studying them. All last week. I'm giving you 0 formulas. So I'm going to rewrite that equation, but without the A's, B's, and C's. I'm just going to put parentheses. Oops. That's what happens when I talk at night. The nice thing is that every single number is 1, so doesn't every blank get replaced with a 1? So 1, 1, 1, 1, 1. You don't have to worry about which is A, B, and C. So then just follow the math. Negative 1 plus or minus the square root of 1 squared is 1. I got 1 negative, so negative 4 times 1 times 1. Negative 4 all over 2. What's 1 minus 4? Negative 3 all over 2. How do you write the square root of negative 3? It is not 3i, but that's a popular answer. Remember that I can break that up as the square root of negative 1 times the square root of 3. You cannot take the square root of 3, but the square root of negative 1 becomes I. So this is negative 1 plus or minus I radical 3 all over 2. That is not in standard form. In my world on a test, because it's really 2 answers, right? You can write your answer as x equals, break it apart into its real and imaginary parts, negative 1/2 plus or minus. Then you want to take the I and throw it out to the side. So you've got square root of 3 over 2i hanging out to the side. I'll accept this as an answer with a plus minus in there. Math Excel doesn't allow you the option of doing a plus minus. So you'd have to write 1 with a plus, put a comma, and 1 with a minus, and those are your 2 answers. Questions on that? Now you could take and check to see if this is correct. What kind of a graph should this come up to be? What kind of a graph is a quadratic? A parabola, right? So I want to put into y equals this, and if I have nothing but imaginary answers, how many times does this parabola cross the x-axis? Imaginary answers, it shouldn't cross at all. You're right, it doesn't. Okay? So I put that in there, I hit graph, and lo and behold, it doesn't cross, which is what you're looking for. So that makes sense. And plus, don't imaginary answers come in pairs? And there's 2 of them, so again, that makes sense. So I feel comfortable with my answer. All right, so your homework tonight, you should be up to P-6. You've got so much time today to do it.